Okay, so here we're going to take a look at this idea of a Hamilton circuit. So a Hamilton circuit, right? It's a related type problem, but not exactly the same, right? So to recap on Euler trail, where we did every edge exactly once. Now a Hamilton path is every vertex exactly once. All right. Okay, so Hamilton path is every vertex exactly once. Now this is a completely different problem than the Euler trail problem or Euler circuit problem, right? So Hamilton path, every vertex exactly one. A Hamilton cycle is a path, Hamilton path that returns to its starting vertex. Path that returns to the starting vertex. Okay. All right. Okay, so here, just to show a graph here. So we see a graph here, right? Now we know that it does not have an Euler circuit, right? As we see all these outer ones are odd degree, right? But it does have a Hamilton path. And here we go, Hamilton cycle. Oops. There we go. So it has a Hamilton path. All right. So we see here that every single vertex is traveled exactly once through this highlighted path. Right. Now notice here that we are not, again, it says nothing about traversing all the edges, right? The path, the cycle, the path is strictly for following and hitting every single vertex. Here. Okay. All right. So here, let's take a look at a couple things here. Right, so just because one has, let's say, an Euler trail, we're not guaranteed to have a Hamilton path, right? So for example here, if we take a look at here, this graph here, right? So we saw this previously where we had a Euler trail, right? But for this one, there's no Hamilton path that exists. Okay, all right. Now, this type of problem here, excuse me. Okay. All right, so now this type of problem uh, is not easily solvable in the sense that there's no algorithm that exists to find any Hamilton path or cycle. While there's a nice um, method, a pretty straightforward method to determine whether a graph has a Hamilton, or excuse me, has an Euler circuit or Euler path, right? No such algorithm exists, right? For large graphs, especially, the calculations can get pretty over, uh, well, unfeasible essentially. Right now, this type of problem is something that's called an MP. complete problem, where if a proposed solution is given, it can be verified quickly. But if the task was to actually find one, actually finding a solution is challenging. Right, again, especially in larger graphs, right? In fact, if so, it's a hard problem. In fact, there's no known solution to it, right? And a solution were to be found, then it would simplify a lot of these problems, right? If we can have an algorithm, then that would simplify a lot of these types of problems, right? So again, this idea of a Hamilton path is something that traverses, right, every single vertex. All right, now a Hamilton cycle is that we traverse every single vertex, but we wind up the last the last edge we cover winds us back up in the original vertex that we started with. Okay.